Hello, hello. All right, how's it going, everyone? My name is Philip Ha.
I'm Harsh.
I'm Iris.
I'm Conrad.
And I'm Elizabeth. Our project is about the Asian carp and saving the Great Lakes. So the most obvious question is, why do we care about the Asian carp? And I know that you all know a lot about the effects of invasive species on ecosystems, so I'm not going to go into the specifics, but I do want to point out that this is a 60-pound fish that can eat 40% of its body weight, so it does have a huge effect on the food chain, and it does lower the water quality, which also impacts several organisms. But the main problem is that it's spreading, and we don't want to get it into the Great Lakes because it's a $7 billion fishing industry, so it would have a huge effect economically on how much money can be made, and also because this fish jumps in the water, which would impact recreational activities. So recreational activities make $38 billion in Michigan, which, again, would have a huge impact. Another reason that we care about this issue and want to work on preventing its spread into the Great Lakes is money. So Michigan's Department of Natural Resources is offering $1 million to whoever comes up with the best solution for preventing the spread of the Asian carp. So if any of you up there think you know better than us, go ahead and go for it. You can win $1 million.
All right, so that's a little bit of background on the Asian carp as an invasive species and the effects that's having. I'm going to talk a little bit about capitalism, about the markets, and about the right market conditions for this to succeed, for our plant to succeed. So essentially, Asian carp are very unpopular in America for eating because of, honestly, not a very well-deserved, it's not a well-deserved reputation at all. People just really don't like it and discriminate against it. In Europe and in Asia, for centuries, it's been prized as a food fish. It's eaten, regularly, and it's prized for its white, tender, flaky flesh. It's a very good eating fish. However, people don't do it because there's a lot of bones. There's a prejudice because the common carp in America, sometimes when it lives in muddier waters, it can taste a little bit muddy and not great. But if they're raised in right conditions and they're raised, in clean water, they taste very, very good. It's really just the bones that Americans are too lazy to pick out that we don't like, so we don't eat it. But there are other kinds of so essentially what I want to say is we have the domestic market that there's a lot of potential for, because there's a lot of economic opportunity in these fish, not just in eating, but also if you look at these graphs in terms of being a good source of omega-3 fatty acids, which are becoming very popular in modern consumption in modern society, as well as high-protein fish meal. The bones and other parts of the fish that aren't used for actual, human consumption can be used in animal feed and in other ways like that, which are both booming, as you can see in those graph trend lines. So our idea is to have a two-part solution, a technical solution, which will be presented later, and a market solution, more of like a way of changing American culture to be more accepting of this fish and to increase demand of it by, people domestically. And so one of those ways that we're thinking is to rebrand the fish. So I'm sure you guys have all heard of Chilean sea bass, which is a very delicious fish that you can eat at restaurants and very high upscale, markets nowadays. It's not originally called the Chilean sea bass. It's a very ugly fish that was very unpopular for a long time. And then we rebranded it and decided to start cooking it in upscale restaurants. And now everybody can't get enough of Chilean sea bass. So we're hoping to do the same thing with these carp. A famous chef out of, I think, Louisiana rebranded this fish and called it the silverfin, which I really like. I think it's a very suave sounding name, and I think it could have a lot of success. So what we're planning on doing is having big cultural fishing events where we catch these silverfin. It'll be a two-part. The first part is going to be having all these sports fishermen come in, getting sports fishing associations to sponsor them, and the competition is to catch the biggest spawning female. And so fish, especially carp, kind of have this whole big old female phenomenon where the bigger the fish, the bigger the female, the exponentially more eggs she's going to produce. So by catching the bigger fish and the biggest fish in the rivers, we're hoping to curve the exponential increase of these carp. And as you can see, it's quite a lot of fun. People love getting on boats, and these fish jump right out of the bottom, right out of the water and into your boat and all that stuff. So it's a pretty good time.
Okay, so this is the second fold part of our solution, which is the more techie side. So our goal is to target the eggs, like we mentioned with the marketing solution as well. So a little background on how the whole hatching and laying eggs procedure works. So carps generally lay their eggs in turbulent water, so usually near dams or spillways. And when the eggs are laid, they follow the flow of water and remain suspended in the water. So if the eggs hit the bottom of the seafloor, they die. So we're going to capitalize on that. And the first part of our technical solution is finding when and where the eggs are hatched so we can target them. So there's a model that exists right now, and it's called Flu Egg, and you can actually download it online on your computer right now. And it exists, which keeps track of the position of the carp eggs that are laid based on the flow of velocity in the water, turbulent diffusion, and other factors that are inputted through the program. The model also can tell the effect of the water temperature on the density of the carp eggs and the egg hatching time. So it's still in development, but there's several models that you can download on your laptop right now, and it has been proven to be successful in assessing the location of carp eggs. So as you can see on the slide right now, it's a little blurry, but this is the flu egg simulation that you can actually download, and through it you can input several numbers, and these graphs can actually tell you the time distribution comparing several factors and where the eggs can actually be, the distance from where the eggs are hatched and where the eggs can be. So from this we can target where the eggs will actually be, and then we can target them.
Now, so when you look at solutions, the carps do not hatch around the year. They normally breed in optimum conditions which exist during spring and summer. The three conditions that are like optimum for carps are temperatures about like 18 to 23 degrees Celsius, a low water level which is in the rise of some rainfall, and obviously an alternating of rainfall and sunlight. So these three conditions are when carps optimally breed. And by identifying, having sensors and weather data and some of that combined with the model, we can, to a great degree of accuracy, predict when and where the carps will be breeding, and then use that to kind of have a targeted effect on the carp eggs. Now, I'll be talking about one of the ways of targeting carp eggs, and then Conrad will go on to talk about the other two. So the first one is using kind of sound, acoustic, and ultrasound. So carp, the fish itself, is extremely sensitive to sound. If when all these boats go around fishing in the rivers, when these carps hear the sound of the engine of the boat, they just get really irritated and agitated and start jumping all over the water. And carps are one of the most sensitive, they're one of the most sensitive fishes to sound. So there is no accurate data seeing if there's any correlation with eggs, or if there's a particular sound frequency or a particular sound intensity or energy that has a specific effect on the carp eggs. But that is something we're hoping to look further into and kind of carry more research and see if we can target carp eggs with particular sounds, and then either destroy them or also kind of get them to spread apart and then sink, because carp eggs can only spawn when they're floating in turbulent water. So we can just break apart the clusters, either kill the eggs or have them, sink or be affected in a way. Then we can actually use this to reduce the spawning of carp eggs, and then eventually reduce the population. Now, going back to the thing about, targeting carp eggs, where they are and when they are, this is something that happened in Australia. Australia had a similar problem, and they identified that carps have very specific breeding regions and seasons, and they kind of use some of those techniques to kind of tackle their problem. So those are some, we can learn from that and adapt a similar approach even over here.
Right. So like Harsh was saying, the carp eggs are very sensitive, where the adult carp have no natural predators in North America. So if we can target the eggs, it's a lot more effective than targeting the fish. So one of the ways that we can destroy eggs is messing with the velocity of water, because like we said before, carp eggs, if they sink, they die. They have to be constantly moving through the river in order to hatch and turn into adult carp. So we thought of solutions where you could widen rivers, or possibly have a sonic solution that would decrease the surface tension of water and make the carp egg sink. And in addition to that, now that we know that adult carp have no natural predators, the eggs actually do have predators. So almost all fish will eat other fish eggs. So we were considering introducing natural predators from the region to these areas where carp spawn, because now that we have this model, we can find out where these eggs will hatch. And if we can find concentrations and establish concentrations of predators to these eggs in these areas where the carp spawn, we can kill possibly a larger percentage of these eggs. Yeah, that's it.